Okay, so last time we talked about using math models to write contracts. So we talk about single choice principle, we talk about information hiding. What you really want to appreciate is, without the math models, if you only use your implementation in the contracts, it's going to violate the various design principles as we discussed. If you got trouble, review the lecture, will talk to me. Okay? So now, what we left off was this particular problem about birthday book. Okay, before I review the birthday book, I would like to just give you a little bit more help on using the math model, specifically how you can use domain, range, restriction, and also maybe how you can use override. So that will be the feature you have to use for the birthday book, or maybe even in the lab test. Okay, let's talk about it quickly. So what I would do is I'm going to just switch the iPad directly, and then I have some concept to explain to you. Okay, so now let me just see this very quickly. So now, the way to think about relation, there are two ways for you to think about it, okay? Either you can think about it simply just a set, right? This is our set notation. It can be just a set of pairs. That's one way to think of it. You can see A over here, B, C, A, B, C, D, E, and F. Basically, we've got A, B, C, D, E, F. You can think about these pink values, A, B, C, D, E, F. Okay, let me just draw a little bit better. Okay, so now you got A, B, C, D, E, F. So these are the 6 values you can have. So they are the so-called domain. On the other hand, let me just use another color. So you got 2, 3, 4, 5, 6, 1, 2, 3. Basically, you got 1, 2, 3, 4, 5, 6, right? So you got 1, 2, 3, 4, 5, and 6. So these are the so-called range values. So how you really visualize a relation is completely up to you. I personally just prefer the set of pairs notation. Okay? But you can definitely use that notation there, which I just drew. I believe that's typically what a math course will visualize for you, what a relation is. Okay? So now, for example, over here, let's see why it is a relation. Relation simply means from any given domain value, it may be associated with more than one range values, right? So for example, you can see when we got A1 over here, when we got A1, so that means A is mapped to 1. Okay, we got one map. And B is mapped to 2 over here. And C is mapped to 3. And also A is also mapped to 4. So now, as soon as you got something like this, that means this is no longer a function. Okay? A function simply means each domain value can only be associated with, at most, one value in the range, right? That's what we learned. Just a very quick review. Okay, let me finish this, and then B5. So B is also mapped to more than one value. In this case, is 5. Okay, we got C6. So C6 over here, and then we got D1. It's getting a little bit complicated, but that's okay. E2 over here, and also we got F3. Okay, something like that. Okay, how you can visualize a relation. You can draw better than I do, but that's kind of one way to do it. Okay, so we talk about all these concepts about relation is supported in the math model library. Given a relation object, you can say R the domain, which will give you all the domain values, right? You can say R the range, which is going to give you all the range values over here. And also you can say inverse. Inverse simply means when you actually used to get A maps to 1, now you got 1 maps to A. Basically to reverse the relation, right? So now basically reverse all the relation direction. Let's say used to get A to 1, so it's now 1 from 1 to A. Just change the direction like this. Okay, that's inverse. Inverse is also easy. Now, what you might have trouble with are, let me just take 2 for example. Domain restricted and also domain subtracted. Okay, for the range version, it's simply symmetric. Okay. Let's talk about what does it really mean for domain restricted and domain subtracted. If you look at the math models class, go to relation class. Not only, let me just take this one for example, right? You've got something called domain restricted, in which case you have to take some input value over here, which must be another relation, just another relation, which means another set of pairs. You can also, you got another one which we'll use in the birthday book. It's called domain restricted by. Okay, in that case, you can simply just put a single pair rather than a set of pairs. Okay, that's another feature you can look into during the reading week. Okay, when you study for the lab test. Okay, I'm just mentioning that to you. Okay, so now I'll leave the mathematical definition here to you. Okay, if you got trouble with it, you can feel free to talk to me during my office hour. Okay, let me just see one example here. So now let's say R over here. Let me use a color here. So let's say R is the relation we're talking about over here. When I say R dot domain restricted to A and B, so what does that mean? That means give me back a new relation, and the only domain values I want to include for this new relation is exactly just A and B. So that means the new relation over there is simply going to include all the pairs where A and B are the domain values, A and B, and also just that. You can see in this case, you can see these are excluded, right? The blue one are simply just excluded. Are you okay with that? Okay, so if you look at the one over here, so this is exactly the domain restricted version. So now there's another symmetric operation here. So what we just talked about in the orange is the domain restricted. What about domain subtracted? Domain subtracted simply means give me another relation, but I don't want this particular domain to be included. Okay, so now if you look at that, that's why I use two different colors to show you. If I say domain subtracted over here, so I want to subtract all the domain values that I specify over here. Let's say if I say domain subtracted, and I simply say A and B, that means A and B should be excluded. So that's exactly why we got this, the blue one. Okay, are we okay with this? Okay, let me give you, if you're not too much bothered by mathematics, let me give you a very simple problem to think about. Okay, so let's say given any relation R and also any domains. Okay, so this is any relation, and this is simply just a set of pairs. Okay, so we have the following property. Okay, if you say R dot domain restricted by ds, okay, and now I want to take the union. So by the way, this is the union operator. You can also check it out for the relation class. Okay, union with R dot domain subtracted, and then I give the same set of pairs. What would this be? Just R, right? We basically either take it or do not take it, right? So you basically union the two together. So the whole thing is just going to be the same as R. You can also do a little test for yourself. Okay? Any question about domain restricted versus domain subtracted? For the birthday book, we got to decide which one to use. Okay, we'll get there. Okay. Okay. If you're okay with that, let me just show you very quickly a very quick test, and then I'll talk about override. Then we are done with the review for the math model. Okay. So now let's look at this particular test over here. This is how you can create a new relation. You can simply make from tuple array. You simply give each element over here, right, as a tuple. So this is this many we have. Okay. So now we are trying to do domain subtracted. You can see domain subtracted is actually a query, which means by calling this, it's just going to give you another relation. We call it T. Okay. So now what's ds? ds in this case is simply just A. When we say domain subtracted, that means I want to have a relation just like original R, except I'm going to take out all the domain value for A. So that means I'm going to take this out. I'm going to take this out. I'm going to, oh, that's it. So that'll be T. Okay, are we okay with that? Okay. And similarly, if we do the domain subtraction over here, that means we do the domain subtract. So this is not a query, by the way. So that's actually why I'm showing you this example. For every operation on the mathematical objects, we got a command version, which does not return anything. You also got the query version, which does return something. For the command version, you want to use in the abstraction function implementation, like append, like what we talked about last time. For the query version, you want to use them in the contracts. Okay, so that's the. Okay, let me just put a very quick notes for you. So those are the things you should really know before the lab test. Okay, this is a query. Okay, use it mainly in the contracts. Okay, this guy over here is a command, which means it's not going to return any new relation. It's simply just going to modify R directly. Okay, and that one is use it in abstraction function implementation. Okay, we'll see. Any question about this test over here? A simple one. Okay. Guys, are we okay? Subtract, well, domain subtract simply means I want to give you, let's say domain subtracted, that's a query version, right? It's simply just going to return to your new relation, just like R, except that all the pairs where the domain value is A is going to be subtracted. Yeah. Domain subtract is simply a command version. Okay, okay, even highlight the different, yeah. Basically, conceptually, they're doing the same thing, but they're different in this following sense. If I try to call R.domain subtracted, in this case, R is not mutated. That's why we said these kind of queries are immutable queries, right? So R is not modified per se. However, when I try to say R.domain subtract, in this case, R is mutated. Exactly. So that. Yeah, the first one there does return something. That's why you say T is assigned to the return value. And the second one there doesn't really modify. Sorry, it does modify. Right? It doesn't return anything. Okay, is it clear about the distinction? Good. All right, one more operation to talk about. Okay, this is something called override or overridden. By the way, this has nothing to do with overriding a method in Java. Nothing to do with it. Okay, don't get confused. We're talking about mathematical overriding. The idea is very simple. Okay, we're going to use override as well for the birthday book. In general, if you have a relation R over here, okay, and then you're trying to say overridden, I believe in the mathematical in the math model, you say either overridden or you can say overridden by. Either way. When you say overridden over here, it's going to take just a set of pairs. If it's an overridden by, it's just going to take a tuple. For example, I can say A followed by 3. Okay, either way. Okay, just make sure you're familiar with both. So now, what does it really mean for override? You can think about overrides doing two things, two steps. Okay? First of all, it's going to see what the domain values are involved in the argument. In this case, A and C. And then we simply do some domain subtraction. We want to subtract everything that's to do with A and C. Subtract them first. Okay, what does that mean over here? If I just repeat this particular relation over here, okay, let me just put it here again. I will really make sure you understand this. So now, can I just do a little bit copying very quickly? So I got A1, I got B2. You know, let me just maybe be a little bit concise over here. So I got A1, I got B2, I got C3, I got A4, and also I got B5, I got C6, and also I got D1, I got E2, and then I got F3. Okay, that's kind of the R I'm talking about, right? Okay, you can think about, of course, I got the brackets over here. So now we want to understand what overriding really means. Think about it in two different steps. In the following. First of all, we are going to take the domain value for the input relation. Okay? In this case, A and C. We simply take out all the pairs in R that has to do with A and C. In this case, we're going to take out this guy here. We're going to take out this guy here, and this. That's the first step. That's the first part. Okay with this? After taking these out, we're going to do a second one. The second one is simply say, now, because you can think about relation as a set of pairs, we're going to union the input relation together with the current relation, which means we're going to add in A3 and also C4. That's what we're doing. So let me maybe put it in different color to tell you it's a different step. The first step is in pink, and the second step, we're going to add in A3 and also C4. Okay, that's override. So two steps. Do a domain subtraction first, and then you try to do a union. Okay, that's the two-step version. If you want to go a little bit quicker, you can simply think in this way. Okay, that's a two-step version. You can think about, you simply go to the let me undo this very quickly and then show you again. So that's the two-step version. The one-step version goes like this. I look at that, I see I got A3 and I got C4. I simply want to replace any pair that has to do with A and C and replace them just by these values. So which means over here, I'm going to replace A by 3. And also over here, A by 3. And also C here, C by 4. That's basically what I'm doing over here, right? Conceptually, you can think about that. Just to replace whatever the key value is with the corresponding value in the domain, in the range. Yes, if there's a domain like that. Guys, are we okay? Overriding might be the most complicated one you have to understand for relation. Finding all the pairs whose domain values match the one in the input, A and B. A and B, and then replace the corresponding value by what you supply in the input, right? Yes. Guys, are we okay? Okay, good. Everybody seems happy. Good. Maybe. All right, let's now we got enough math background, so we can talk about birthday book again. So now let me go to the birthday book over here. So we talked about the functionality for the birthday book last time, right? So now I assume you're familiar with it. So now what we're going to do is I'm going to present to you two bond diagrams. We'll learn from the bond diagrams, and I'll ask you how to write the contracts. Okay. So we're going to focus on these features, the number of entries, and also how can you actually add in a new entry, and also how we can remove some, let's not remove will just be an exercise for you. But the fourth one is more interesting. How do you find the birthday of a set of people, right? Given the range value, how do you know all the domain values that match that, basically? Okay, we're going to see that. Okay, so now we talked about design and implementation decision last time, so I'm going to go skip that. Okay, so now let's talk about design, right? Let's say if ever I have to refer back to the example, let's say this is one example to visualize a birthday book. Let's say, again, we got three people here. We got Alan, we got Mark, we have Tom, right? Let's say Alan and Mark and Tom, they were born both on October 15th. And Alan was born August 11th. The year is not important here, okay? So now that means if we want to remind whoever was born on October 15th, we should return both Mark and Tom, right? If we just want to remind August 11th, we should return a singleton array containing Alan. What about if we want to remind February 13th? Empty, just empty array, okay? Good. So we got some reasonable intuition about what we can do, okay? So now let's go on to the bond diagram, okay? So well, the one that's blocked is something that you have to figure out for us. Okay, we'll do it together. Let's see the let me figure out the easy part first. Okay, so now we have birthday book class, we have birthday, and also we got name. Okay, you can see for the name class we can try to do, let's say there's an item called string, right? So you can see that it's a design decision. We didn't really just use the string value as a name directly. We make it a class called name. The reason is because the name can only start with, let's say, a character, right? You shouldn't really have at something, right? So that's not a valid name sequence. So that is why we have a name class over here, and then we simply got some attribute string, and we say that it will only be considered as a valid name if the first character, for example, is either A or Z, well, from A to Z. That's a range. It's a very important point to understand why we're using name class rather than just using a string for the name. Are we okay? Okay, good. Yeah, of course, in your lab 4 and also later in the projects, you're allowed to create as many classes as you wish, as long as you can justify that. Well, justify in the sense that why do you need this class, right? Okay, you can see over here, the way I justify why I'm having this name class is because if I simply say, let's say this, in the birthday book, if I simply say, let's say I have this particular name is of type string, versus name is of type name. There is a fundamental difference over here, right? If you think about version number 1 over there, version number 1. At the runtime, if I simply say name is simply just pointing to some string value, let's say at hash some junk over here. This will be okay if it's just a string value. On the other hand, if I try to create an object over here, let's say name, which is pointing to a name object over here, and then you can see there's an attribute over here called item. And then if I simply do this, let's say also try to create something like this, what's going to happen if I attempt to do this? What kind of violation? Invariant violation, exactly, right? So now this simply would not be allowed. So this is why I'm justifying why I'm having this extra class. So this would not be good. It's an invariance violation. I have a little quiz for you before I answer your question. You can answer that too, okay? We are using something similar to this in Lab 4. What is that? Aha, Battleship alphabets. Exactly the same reason. Okay, now you see 2 examples for this. Very good, very good. Yes, you still have questions? Yeah, I'll come to you, yeah. Can you do a, what do you mean?
So you can still do the string value.
Yes.
When you do the function to add a name to it.
Oh, you can still have a precondition, right? That's true. So what you're saying is, rather than having a separate class, you definitely can use that. You can say, whenever I want to say add, let's say add a birthday, and then here I say s of type string. For example, over here, and then you simply got to require over here, and they can repeat this particular Boolean, right? That will work. However, this is not as good design, because if you put a class called name, you can reuse it for as many times as you like, among different clusters. However, for this one, you may have to repeat it for many times, which violates single choice principle. Yep. Good. Well, simply it says the following. Well, of course, this is not complete. We simply say item, which is a string, at position 1. Simply say the string does not always has to start with a character that's between A and Z. Okay. Yeah, of course, you can make it more complicated if you like. Yes. How do we deal with? We'll get there. We'll get there. Good question. Oh, you talk about birthday, right? Okay, we are only talking about name. I like that. Good. Okay, so now let's go to birthday here. So that's about the name class. Let's talk about birthday class, right? So now I'm proposing something I can tell you right in the front. It's not complete enough, okay? I'm saying that a birthday will be valid if the month is in between 1 and 12 and day is in between 1 and 31. I agree, first of all, it does not account for leap year. Okay, I'll get to that point. What else? Exactly. Here you can also have February 1st. Oh, sorry, February 31st or February 30th, right? So now, if you really want to make it complete, that'll be an exercise for you. How can you make it, let's not worry about leap year just yet. How can you make it complete? Something like that. Let me suggest something. If you can simplify that, you got questions or you got suggestion? Huh? Yes. So I'm trying to say this one is not good because if I try to, let's say I keep this invariant over here. If I simply got the month being, let's say, February, and the day being 30th, right? It's going to satisfy this invariant, which is not good. It should not satisfy. What we're expecting from here would be an invariant violation, but it wouldn't give you. So that's why it's not complete. You can do imply, suggest something to the class. Yeah, something like that. You can say, let's say M for month. You can say if month is equal to 1, or the month is equal to 3, etc. That implies the day should be equal to 31. Something like that, right? Can you see the structure here? So basically, antecedents for the implication is going to be a disjunction, and then implies the day is going to be 31st. And also you can say if the month is equal to, either 2 has to be dealt with maybe together with leap year. Okay, so it will be 4 or 6. Okay, I trust you. Okay, something like that. That implies the day should be 30. Good. Now, what about leap year? I believe it's a leap year, then February should be 29. Otherwise, it should be 28, right? Good. What's the definition for leap year? No, don't worry. It's not in iPhone 101, don't worry. I'm not blaming you for that. Yeah. No, actually, okay. So to be a leap year, you can look it up in Wiki. I still remember because it's one of my lab tests for 1021. So it will, given a year, it will be a leap year if it's a multiple of 4, but not a multiple of 100, or it's a multiple of 400. Anyway, look it up. It's not important. Okay, you can look it up. And how do you encode this guy here into this particular class? But notice one thing. There's no year information here in the birthday, right? So maybe we want to extend that with the year. Exercise for you. Okay. Don't worry. I can tell you having leap year is not in the lab test. Okay, I can tell you. Okay, don't panic. But we might give you the definition for leap year in the exam. Ask you to translate it, right? Exercise for you. Let's say year is another attribute over here. Let's call it integer, just integer type. So now you want to have something like this. You want to say, is leap year, that implies the day for February, and also, okay, by the way, I think, let me be more complete for you. And also, it's leap year, and also the month is simply just 2. That implies the day should be 29, something like that. Okay. Now, if leap year is something you can look it up. Okay, just this exercise. Are we okay with these two simple classes? Okay. Now, a little bit help on you for you to draw the Venn diagram. You can see that over here we got birthday and we got name. So these are the supplier classes, right? So now we want to figure out exactly how to draw the client supplier between birthday book and these two classes. For example, so now, let's have a look at the signature very quickly. We have a model feature over here. We have count, we have put, we have remind. Okay, so these are the 4 features we have. So now, from which one of them can you see a client supplier between birthday book and birthday? From which feature? From which features? It's an important question for you to understand, right? Okay, let me repeat the question again. I claim that there's at least one client-supplier relationship between the birthday book and the birthday. But how do we see that in the declaration of the features? Huh? Which feature? Tell me which feature it is. Put, okay, good. So now at least we got over here, you can see the put feature here. We're using birthday here, right? Anything else? Remind, thank you. That's also a birthday over here, right? So this tells us we should have at least one client supply over here, right? Let's say we want to use one of them. Let's say we want to draw the client supply for the remind. So now the question is, how do you put this label over here? Okay, how do you put that? Okay, let me just show you the answer directly, okay? That's something you can also look at yourself. Oh, actually, I look at the, there's also model. I simply forget. Okay, we also got model over here. You can see there are actually 3 client-supply relations between the birthday book and birthday. You don't have to show all of them. Just show one of them will be okay. Okay, in this case, you can see the model feature here is using birthday. So that's why we simply mention the name of the model in the label for the client supplier. And then notice one minor detail over here, right? Because we know that it's already this particular arrow over here is going from birthday book into birthday. So we know the target supplier is really birthday. So you don't have to repeat the birthday again in the label. So this is why you will see in your diagram, we simply put ... over here. So that means the model is of type function. The first generic type is simply name. And the second one, we know that it should be birthday, but in the label, we don't say birthday again. We don't repeat. We just say ... Because a minor detail over here. Huh? It wouldn't be wrong. I'm just saying it's a convention. It wouldn't be wrong. It's okay. Yeah. Okay, now, can we just do one more? Okay, what about this particular client-supply relation over here? So where is the client-supply relationship between birthday book and name? What's the feature? Okay, we got 2, right? So it can be, actually model. It can be model, it can be put, and also it can be over here, right? Okay, let's say we choose to do remind. Okay, this is how you can write. Okay, similar idea. So we are saying that we are mentioning remind over here, and remind is of type array of simply name. Of course, this could have been ... But if you say name, that's fine. Okay? Either way is okay. Okay, are we okay with the labels? Okay, so now let's talk about contracts. Okay, that's really important. Okay, so far when we talk about how to draw the diagram, that will help you for lab 4 and the projects. But now let's help you with the lab test. How do you figure out the contracts for each one of them? Okay. For now, let's say we only worry about the model contract. We'll talk about implementation in the next slides. So now let's say the model over here is simply just going to be a function. Very quick justification. Why does it have to be a function as opposed to a relation? Yeah, no, you cannot have one person who got multiple birthdays. Exactly, yeah. Exactly. So function guarantees, given a particular domain value, you'll give it at most 1. Yeah, the range value. Very good. That's the justification. Okay, good. We're using function here. And then we worry about, so that's so-called abstraction function. And we're just going to use the model over here for every post condition, right? You should never ever measure implementation in short. Okay? So now what about, okay, count is easy, simply the number of entries. You can also use it if you like. So now let's do the put. Okay? So let me give you one example over here. Let's say we got this birthday book here. If I want to add, let's say Jim. Oh, actually, you know what? Let me give you 2 examples. If I want to say put, let's say book.put. Okay? And by the way, notice one thing. The IFO convention is okay, depends. So here, the name over here is simply the key. And the birthday here is just the value, right? Okay? Or domain and range. Let's say I want to put, let's say Jim. And then I want to put, let's say November 29. Okay? Let's have another one. The pink one, let's say b.put. And then if I say, what about Alan over here? And then I would say I'll change that to August 23rd. The blue and the pink, okay, both are possible. Hopefully these 2 examples will give you an idea how to write a model contracts, okay? So now let's try the blue one. The blue one over here, you can see that Jim is not part of the domain, right? This guy is easy. Simply add a pair to the relation. So I simply got Jim over here, and then I got November 29, and that's a new pair. That's easy, okay? What about the second one? I would say the second one depends on how we want to implement the birthday book, right? You can say, well, I simply don't allow any existing name to be added again. That can be a precondition violation. That's one design decision. But remember what I said last time. In our particular birthday book, if you're trying to add add an existing name as a pair, that means you want to modify their birthday. Okay? So what this means is Alan already exists over here. When I say August 23rd, that means I want to modify his birthday to be August 23rd. That's what I meant. So now a very quick check. How do these 2 examples here correspond to in the relation function, in the relation class? What kind of feature does that correspond to? The first one is like a union, yes. Overridden by, yeah. In fact, for the first one there, it's also overridden by. Overridden by is going to work no matter what. If the thing you want to insert, the key already exists, it's going to do replacement. If it doesn't exist, just going to do union. Okay, it's going to work. Okay, very good. Okay, so both of them simply correspond to overridden by. Are we okay with this? Okay, good. Let's come back here. So now that we understand the put feature informally, how do we write it? Anybody? Let's say this is a lab test. How would you write? By the way, you don't want to write false, right? If you write false, then that means it's going to be violated every time. Suggest something. Yes. Go ahead. Insure. Yes, insure. I'm talking about this insure over here. How about start you with? Is equal to what? Think about the model is like a function. The old version of the model is also a function. What's the relationship between the two functions? And we agree in the previous slide, what we are really doing over here in both scenarios are really just overridden, right? Overriding. So now you want to turn that into syntax. Yes, you first. Okay, that's good. That's good. That's good to begin with. So if I say, you're saying old model dot overridden by, right? Okay, let me write it down. Okay, overridden by. Okay, I'll just make it a shorthand. And then we can say, and for the signature, it's going to be a tuple, right? You're going to say name followed by date, birthday. What's the problem for this? I can tell you it's problematic. Okay, if you conceptually, I know what you mean, but if you put this in the lab test, you're going to fail. Okay. Anyone? Think about what we said in the complete post-condition lecture. Especially, yeah? You got to do deep twin. Why? Let's review why. Why would you have to do deep twin? Yeah, think about it. Okay, let me just write it down first, and then I'll remind you. You really want to review the lecture a little bit. Okay, let me just write it down. So what you really want to say instead, rather than saying old model, you want to say something like this: old model dot deep twin. Yes, you want to explain? Yes. Yes, if you only say old model here, that means the way Africa is going to cache is by using a reference copy. If you say old model dot deep twin, that's going to guarantee any malicious post implementation cannot really modify the underlying structure, right? Questions? Or? That's exact. Oh, you want to explain? Yeah, you can try again. Yes. Correct. Because, yeah, that's also right. Yes. If you don't use old model.deep twin, any change you make in the implementation just cannot be visible between the two versions of the model, right? Good. Okay, guys, I presume you're comfortable with it. Okay. If you're not, please refer to the post-condition lecture. Okay. So now that's exactly what you will get over here. Good. One more detail to mention to you. In the lab test, it would be absolutely fine if you simply use overridden by. That's not a problem. However, do explore for yourself. You can also use this infix operator for the overridden by. Okay? At, less than, plus. Okay, oh, first, don't memorize this, right? Don't memorize that, yeah. Huh? Yes, I'm just saying, during the lab test, you can feel free to either use this or use overridden by. But, you know, my personal advice, use overridden by. If you actually either type one character less, you're going to get syntax error, and nobody's going to help you on that, right? For your lab project, for a project, it's better to use the symbol. It's more elegant. Okay? Well, they have the same impact, right? I'm just saying either use the normal feature call or just use a symbol, either way. I'm just saying in the lab, since you got time to actually think about if you run into errors, right? But in the lab test, you'll be under pressure, so you wouldn't know how to fix it. Okay, let's see. What about remind? Now, let me give you a little bit connection here. Remember, we talked about exercises about a post condition before, right? We're saying that we want to return, given an array, we want to return all the numbers that are actually positive. It's similar to this, similar. Although we give you another solution in a different flavor, okay? So now, basically, you're talking about a relation there, and then let's look at the signature. Okay, let me give you one example. So now, let me just say over here, blue. Okay, if I say birthday book dot remind over here, If I say remind on October 15, okay, it is going to return an array of name, right? In this case, what should we return? Nothing? Are you sure? October 15, right? Oh, really? Oh, 15, 15. Yes, 15. Sorry about that. Okay, October 15, and should be Mark and Tom, agree? That should return Mark followed by Tom. Okay, let's do another one. What if I say b.remind? Okay, if I say, what about August 23rd? Alan, yeah, Alan has been changed, so now I can say just Alan. Okay, just for your completeness, what about I say, let's say b.remind, let's say today, February 13th. Yeah, nothing, yeah, empty array. Not null, but empty array, right? Good. Good, okay? So now, how do we write complete model contract for this? This one is a little bit trickier. It's worth thinking about it because you might have to deal with something similar in the lab test. So I'll rather not show you the solution directly. Think about it. I tell you what, you can definitely use the across, but the idea would be you may not have that much time to spare in the lab test. So why don't we do it? If you can do it simpler, why not? One thing to mention: the reason that we had to use across in the beginning of the course is because we didn't learn about math model just yet. So we only got the array, so the only way you can write complete contract on the array is by using across. But now, since we got a math relation, they do have something supported for you already. You don't need to use across. Subarray? Nope, nothing to do with subarray. Range restricted, okay. Yes? Okay, so I heard range restriction, I heard range subtraction. Yeah. Should it be range restriction or range subtraction? All those other. Thinking this way, okay, first of all, we agree that we should really use something to do with range, right? Because the birthday actually occur in the range part. Okay, so now the question is, should we do, for example, if I say birthday dot range restricted. Let's say I simply got, let me just take this one for example. If I say October 15, so what does that mean? That means I'm going to get a sub-relation. Well, I'm going to get a new relation, right? Let me just try to highlight it. If I say be the range restricted to October 15, so that means I'm going to keep only those that have the October 15, which means I will get Mark, Tom, and also October 15, right? That's a new relation I will get. That's a range restricted. On the other hand, if I say over here, if I say b dot range subtracted, October 15. Remember I said before they're completely disjoint. If I try that thing over there, b dot range subtracted is going to be basically just Jim, Alan, November here, and also August here, right? They're completely disjoint. So which one should we use? Subtract or restrict? Good, good. That's how you. I'm just trying to show you how you can justify by yourself. Very good. So now, if I try to say birthday book, that range restriction to whatever birthday you pass to me, it's going to tell me exactly the relation that is going to be restricted to that particular range value. But now, the question is, we don't actually return this particular relation right away, right? Because that one contains the Mark and Tom and also October 15. I only want to return Mark and Tom. How do I get only the name part, but not the birthday part? Yes, absolutely. Which means do a range restriction first and then do the domain. Absolutely. Okay? A very common error is you simply write this in the lab test and worry and don't know what's wrong with the compiler. Nothing wrong with the compiler. Something wrong with your thinking. Okay? Make sure you do the domain part here. Good. Okay, so now let me show you the particular solution I have over here. Okay, so now let's do one by one. What should be the size of the resulting array. The size. It should correspond to the size of the domain of the range restriction, right? Okay, so that's the first one. Oops, you know what? I don't want you to see others. You should use this smaller one. Sorry, pretend you didn't see it. Okay, oh, the first one. So this is something important. Because the remind is a query, that means we don't really modify anything, right? We only return something. So this is important to say model is the same as all model.deep twin. Nothing has been modified, right? And the second one is really about the count. So the second one over here is going to be, okay, like that. Okay, I can do a little bit better. Sorry, it's a bit slow. How about this one here? Can we understand this part before we go to the last one? I'm saying that result, which is an array.count, should be the same as model.range restricted by d.count. Very good question. The question is, let's say we talk about this particular post condition over here. So now, do I have to say old model.deep twin? How do you know we didn't change it? Where did we make sure? Yeah, exactly, right? So that's why. Because that's why the order of putting the post condition is really important. If we could reach this point here, that means this one is already passed. So that means over here, starting from here, mentioning model versus old model.deep twin are equivalents. Okay? Not necessary. Okay, guys, are we okay with the first one? So this one simply says that the size of the array will be the same as the expected return size. So now the third one. Okay, the third one is you might need a cross in this case. Okay, the third one here, basically I want to say every name I collected in the array, in the resulting array, is indeed mapping to the expected birthday. How do we do that? Anybody want to try? I do have some space for you over here. I'll start you with a little bit quick, let's say, I would say it depends. In this case, we do need a cross. How about this? I would say always leave that to your judgment. Okay? Sometimes you might need a cross, sometimes you don't need it. Okay? Okay, let me start you with, and then I'll see if anybody can help me complete it. So if I say across result, across the result as some name, okay, for example. Should I use universal or existential? Universal, right? Good. Very good. Anybody? Basically, you want to say every name in the result that's being returned indeed have their birthday on whatever that's being queried. Model, yes. Basically, model is a relation, right? Model is a function. I want to do some function application. This model applied to this particular domain value over here should give me the expected value, right? You see what I mean? So you can look it up. So you can model.item. Okay, I believe you can also use the infix notation like this. Model query on, let's say in this case, the input argument is simply just D. Okay, so that will give me the birthday, right? The corresponding birthday should be the same as D. Sorry, let me say it again. I got messed up, sorry. What I meant was model query on this particular name is going to give me the date that's being queried. That's what I meant to say. Make sense? Yeah, good. Actually, it turns out I just give you another possible solution. The one I just put on the slide is different. That's okay, either way works. Okay, so you can choose whichever version you prefer. What I'm trying to do here, I say every name I collect in the result has the corresponding birthday being queried. So what I just covered, I'm going to uncover that. Basically, I'm saying every name that maps, every name that's mapped to the corresponding, that's mapped to the expected birthday is collected in the result, the reverse way. Okay, let's have a look at that. Okay, so you can use either way. Not a problem. Okay, so now I can cover that completely. Okay, so now let me highlight it for you. Basically here, but that one there, I simply say for every name in here. So this one I didn't really put in iPhone syntax for you, but okay, how about we translate it together? But let's just try to understand that together first. So here I say that for every name that is a model.range restricted by, so again across this particular guy here, right? And then name will just be in the result. Okay, that's a second way of writing it. Should we try together? Okay, I'll translate it for you. Okay, add a page below. So what we can say is, you can say across. Okay, and over here I can say model dot range restricted by, and then over here I can simply say D. Okay, and then I can say domain. Right, domain here is really important. Okay, you want to say all the names. S, and then I simply say result dot has and dot item. So we got two versions for you. Either you can go for this version over here, or you can go for version number 2 over here. Either way, depending on what's the target being across. I said, okay, good, very good. Okay, if you're okay with it, so now let's go on. So what about invariants over here? I'll show you the invariant that we can possibly write. You want to make sure, since now we got two notions over here. We got a model, and also we got the count. You can see this count over here tells us that's the size of the book. I want to make sure always the size of the book is the same as the size of the function. Okay, so now that's why you see something like here. Okay, you can see that over here. We say count of the book is the same as the count of the model. Right? That's one example invariant, right? Okay, quite many things to learn from this example here, right? That's only about design. Let me just do a very quick final detail about implementation. So now this is the implementation here. Basically the same architecture, the same, except that now we introduce the notion about implementation. And in this case, let's say we use a hash table. So that's also something you should really try to get yourself familiar with. Right? Hash table is going to give us maybe the best performance. Okay? So now let's say the hash table over there. Okay? Question? You're fine? Yes. Okay, sorry. I thought you raised your hand. Okay, good. So now let's say this. Okay, so we still got model, we got put, we got remind, and then we also got some invariants over here. Okay? So now what I really want to focus on is the model part. Okay? Now that we decide what the implementation should be, so there are two things you want to do. Okay? Number one, you want to make sure in the implementation part for the model, which is over here, you want to make sure you promote. When I say promote, I simply mean convert. Whenever you call model, you have to convert the hash table into a function. Okay, that's the part you have to do using commands. On the other hand, for the ensure part over here, you want to make sure the model we get as a function is consistent with the implementation as a hash table. So both parts are important. Okay, I will talk about just the contract part, postcondition with you. But for the do body over here, we also made the source code available for you to both sections, so you can also download it. I'll show you the way you can download it. So now over here, when we have ensure over here, okay, any suggestion, quickly? I'll give you a little bit hints. The way to write this particular ensure will be very similar to how we did it for the remind. Very similar. Basically, I want to make sure the size of the resulting function should be the same as the size of the hash table. Right? They should be of the same size. And also, every pair in the hash table should correspond to some pair in the function, conceptually. Right? But how do we write it? Okay? Let's see that quickly. Okay, the first part is really easy. You can simply say, over here, I say result account is the same as implementation account. Agree? Okay. The result over here is simply just the function. I'm saying that it should be the same as implementation, which is a hash table. The count should be the same, which means the number of entries in the hash table should be the same as the number of pairs in the function. Okay, that one's easy. Okay, what about the second part of the post condition? How do I say it? Something like basically every pair in the resulting model function is also corresponding to some entry in the hash table. How do we say that, right? That's your job. Okay? Why don't we just look at the solution quickly, and then that'll be it. If you look at the solution over here, one possible solution. Again, I simply give you a mathematical formula over here. Okay, let's try that. We say for every tuple name and dates in the result, which means this is the function. Oh, sorry, there's a function. Basically, so what are we going across to? We're going across over the result, which is a function, right? And then we're saying that every tuple we are considering in the function should be a member of the implementation. Okay? So maybe for implementation here, you may want to use the feature called has in the hash table. That's a little hint to you. So now your job is to translate this into iPhone. Okay? So it's going to be a very similar translation as before. Okay, any question about the birthday book case study here, right? Which one? You mean here? You mean here? Oh, you mean, oh, I see. So if you look at the slide, it's going to say promote. Promote simply convert. You want to convert from a hash table into the resulting function. Yeah, pretty much like how we convert from the linked list into the sequence for the stack, right? Similar. Okay, any questions? Okay, let me point out a few references to you, and then we are done with this topic. Okay, that'll be your lab test 1. Okay. All right, let's have a look. Okay, so now if you look at the references, so now for the lab test, you have to be familiar with sequence, relation, function, and set. So these are the main classes you want to be familiar with. Okay, they're pretty much similar, right? And then if you are in, the source code for the birthday book in iPhone is simply available here. But I would suggest the following. Maybe it would be your best interest not to download it right away. Okay? You may want to, based on our discussion from the 2 bound diagrams, can you reproduce executable iPhone code from that? Yeah, it's absolutely possible. Right? Why don't you do that? That would be a very nice rehearsal for your lab test. Okay, but the code is always there. Maybe after you're done, you can take the code and compare that. That would be my advice to you. Okay, good. And then I have an exercise for you. After this, I would like you to replace the implementation being a hash table. In some way, conceptually, a hash table and a function is very similar. They both got a notion about key and value. I want to make the implementation even more unlike the model being a function. What about we have 2 arrays or 2 linked lists? Okay, I will show you what I mean quickly. So that'll be also a very nice exercise for you to try. Okay, over here, so what I would do is, so now what I mean by is this. If you look at this particular birthday book, right? So rather than having a hash table, what I want to have is something like this. I want to have 2 arrays over here. So now one array is simply the names. So I got Alan, I got Mark, I got Tom over here. And then I got another one, which is the birthday. And now for Alan, it's going to be some birthday here. For Mark, it's going to be some other birthday here. And for Tom, it's something here, right? So the corresponding position in the 2 arrays is going to make you a pair. So try this particular implementation, which is going to be much less efficient. That's OK. But the main thing is about practicing the math model. I have a question for you. Okay? If also again, finally to test your understanding about the whole lecture. Let's say I used to do hash table for the birthday book. Now I want to migrate my implementation from hash table into 2 arrays. What should I change? Of what? The implementation of put. When you say everything, that's not very precise. Oh, Okay, let's look at this diagram, this bound diagram here. Okay, what do I have to change? Which part of the put? Just the implementation or the contract as well? Just the implementation, right? Because implementation is going to depend on now two arrays rather than hash table. But what about the contract over here? No, right? But it depends only on the model. Okay, same as the remind, which I'll also only change the implementation, but for the model contract, it's going to be the same. What else? Conversion. So I also have to change the model over here, which means I got to change this part over here and also this part here. That's the single choice principle. You got to change this set of places, especially the abstraction function. But once you have done that, all the contract view remain the same to the clients. Okay? And so two exercises for you. Okay? That will prepare you very well for lab test. Okay, so exercise over here. And if you are wondering about how you can implement a birthday book using two arrays, feel free to refer to this particular tutorial which I made for 2030. If you want, refer to it. But it's quite long, so you may just want to go over that when necessary. Okay, and then you want to, okay, that's exactly what I just mentioned. Maybe create a new class called linear birthday book, and then try to see how you can change the implementation for the abstraction function. Okay, and make sure all the contracts still pass. Right? If any one of them actually failed, that means you got some problem for your new implementation. Okay, any question about the math models? Are we okay? Good. We still got about 15 minutes or so. Okay. I tell you what, I really try to see if I can schedule a makeup lecture for us during the reading week. Apparently, I'm not allowed to do that. It's simply forbidden by the university. You might actually like that, right? So, but the thing is, we're kind of behind because we got one lecture cancellation. So we don't really have the inheritance cover to the point that I would like to cover. So what I will try to do is maybe I'll try to go a little bit faster for some part of the lecture, maybe after the reading week. I'll try to cover as much as possible today. After the reading week, we got to speed up a little bit. Okay? Because inheritance is really important to understand before we study more defined patterns. We'll see what we can do. Okay, so now I want to do a very quick review on this particular architecture that we talked about before we talk about math models. Okay? Okay, basically we talk about this as a case study. So now we switch the gear back to inheritance. Okay? No more math models. So this guy here, okay, let me just remind you what we are trying to do for this particular example. We have a class called account, and then we have a feature called withdraw. And the withdraw specifically have this particular post condition over here, which is say the balance. Oh, can you see it? Sorry about that. Now you can see it. Okay. So we have the account class, and then we got a withdraw feature here, and then we're saying that this particular post condition, the balance must be the O balance minus the amount. Okay. Yeah. Okay. So now what we want to really do, which you really want to try for your lab form projects, because you may have to, you may write some contract you would like to test, right? So now, how do I test this particular post condition? Which means I may want to create some scenario which I think the post condition should really be violated. I want to make sure it's really indeed violated, right? So now how do I do that? Okay, what we said last time very quickly, and I'll show you very quickly on the iPhone Studio. So what we have to do is create a subclass over here called bad account withdraw. And then we simply just redefine the withdraw feature here, and we can use the precursor keyword, which is like a super keyword in Java. And then we simply inject some wrong implementation. Okay? What's going to happen is what's going to be interesting is on the client side. Let's say you try to write a test to say test withdraw post condition violation, and then you can see an ACC account is just going to be of the same type as the bad version over here. That means when you are trying to call this particular ACC that withdraw at a runtime, which I'm going to show you, if you try to, if you try to run a debugger and see which version of the withdraw is being called, in this case, you're going to see that it's exactly this version that's being called. That means you're going to do the wrong implementation, and then the post condition is simply just inherited to all the subclasses. That's something we'll talk about after the reading week, and it's going to cause a post condition violation. Okay, the source code is actually made available to you. So let me demonstrate to you very quickly something you want to pay attention to when you see the debugger. Okay. Okay, so if you download the source code, you're going to see some test cases over here. I'm just going to have something called test account. Okay, so now let me point to you the class you can look at. So I have one class called bat account withdraw over here, and then it's going to simply do precursor and also the wrong implementation, well, as I just illustrated. Okay, so now what I want to do, if I go to the tests over here, test account. So now one more thing to show you. The way to use this is really important to note. If you want to test for the post-condition violation, you must use add violation case with tag, because you want to see which post-condition specifically I want to trigger to violate, right? It's really important. And don't make any typo here. If you make any typo, you're gonna get some other error, which you can never figure out. Okay? And then you're gonna put agent and then over here. Okay? Good. So now what I want to show you on the iPhone Studio is like this. Okay? Quickly. So now what I want to do is I'll put a breakpoint. So now I'm in the test withdraw class, and then let me go to the flat view. Okay, test withdraw. Actually, let me just see which one. Test withdraw post condition. Post condition violation. Okay, I already got a breakpoint over here in the beginning of test withdraw post condition violation. The only thing I want to verify together with you, when I reach this point to say ACC.withdraw 50, if I say step into that particular feature call, which class should I step into? Should that be the account or the descendants? Descendant, right? Let's double check. That's the only thing I want to show you. Okay, that's how things work. Okay, so I was simply just going to run the debugger. Okay. Okay, so I will say run over here. It's gonna stop over there. Okay, now we're here. Okay, so now I would say step over. Okay, step over. So now I'm pausing right before trying to execute ACC.withdraw. Now, if I say step into, we will switch the context to another class. So which class? Bat account withdraw, right? Let's do that. Step into. Okay, exactly bat account withdraw. We are here. And notice that if you, let me do another thing. If I'm now right beside precursor amount, if I say step into, would I stay in the current class, or should I switch back to some other class? Switch back to the account, which is the parent class, right? Let's double check with that, and then we're done. Okay. Okay, and then if you say step into over here, that means we're back to the account to execute whatever that's in parent class, and then do something more. Good. Hopefully you got it. Okay, that's something you can really feel free to reuse for your lab form project to test your contracts. Okay, that's really an important part for the course. Okay, so now we got about a few minutes. Okay, you know what I would like to do now is I want to stop here. Okay,